In the first video, we talked about, what the limitations were of you're using a battery to send power to your house, or for anything else, I guess. 120 volt power. In this one, we're going to talk about what happens when you hook it up to an alternator in a vehicle and have an inverter there, and what can you power with? How much power can you put out with this thing? So let's get into it and see what this is going to do. Now here we're looking at a fully charged battery again, 13.36 volts, which is about right. We're going to use our 1 kilowatt load, or more or less 1 kilowatt load right there. It's just a heater. And I'm going to give this a fairly long-term test and see what if there's any failures in this. And I'll give you some calcs during the way for total amount of power and so on like that. I can give you an accurate idea of exactly how much power is being used by that load. I think it's a little more than 1 kW, but we'll get into that in a little bit. Okay, have the engine running. We're up to 14.3 in voltage. Now I'm going to be checking amperage here when we get loaded up. Okay, what's coming out of the alternator is 76.5. Now I'm going to check voltage at the load. Okay, 119.2, we'll just call it 119, and we will check amp draw, and we are at 10.75. Now if you notice, the element is glowing. So we are burning up some watts. Now after about 8 or 9 minutes, our voltage has dropped down to 11.87, and it's probably going to drop a little bit more than that because we're pulling power out of that battery in addition to what's coming from the alternator. Now here, this is going to be the part that bothers me a bit. Now I'm going to be checking the temperature of the alternator. Now, in various places it's going to be at various things, but we're at 185, 84, looking at the winding, pretty high. Yeah, we're at almost 200, 195 degrees. We've only been going about 10 minutes. That's where probably our weak spot is going to be, is in the alternator itself, because I'm not sure it can handle that kind of temperature for long periods of time. Now this thing is rated at 135 amps at 12 volts, but they're just not capable of doing that for any length of time. This thing is made to charge up a dead battery. Like if I had a dead battery and I got it started, to jump or something, then it's going to throw a bunch of charge into this battery. But it's not going to be for but maybe 5 or 10 minutes before it stops dropping down, because the battery's going to start getting charged. So this is a continuous load. And here we can see we're starting to drop a little bit more on this battery. If this thing continues to operate this way, it's going to drop down because we are losing on the battery. Remember, we're putting 70 amps in and we're pulling 120 out. It was 130 at start and it dropped down to about 120 after a little while. So we are slowly dropping the battery charge. So we're using up battery and we're maxing out the alternator. And even though it says it's 135 amps max, I don't think you can expect even half that much out of it in a continuous operation. So we'll do some calculations on this and see what we come up with. Okay, now what we've come up to now, we're showing about a little under 11 volts coming out of the battery. So the battery's been slowly dropping down. We've had this on about 35 minutes. And so now you hear the beep beep coming. It's going to continue dropping down and it's going to end up shutting off the inverter because the voltage is too low. So the alternator is not putting out enough power to keep the battery up, so the battery has to make up what's left. And well, let's see what our amp draw is now. Our amp draw is down to 109, pretty close to 110. One other thing I want to check while we're here is the temperature of the alternator. Okay, the temperature of the alternator, it's up there, depending on where you're looking, 215 maybe. So it's getting pretty high. Okay, I'm going to go ahead and stop the test at this point, and we'll look over some of the numbers. Quick summarization of what happened here. We had a 1273 watt load with the engine running at idle, and we went for 35 minutes and then the inverter shut down because the voltage in the battery was too low. We were pulling too many amps for the load. The alternator was not taking care of the entire load, so the battery had to come in and take care of it. And of course, the battery eventually runs out of charge. That's what happened. So we can't have that high a load. So how high a load can we have? What can we actually put in there that's going to that we could operate steady state? So that's the next part of this test. I'm going to start this test and we'll see how it works out. Okay, what I've done, I've fiddled around with loads until I've got what I think is about the maximum that the alternator will produce without discharging the battery. So we notice we're at 14.19 volts. That means that the alternator is actually putting a little bit of charge into the battery. Remember, it would drop down in the 12s to start with when we were reducing battery capacity when we had the larger load on. So let's take a look and see what the amp draw is from the alternator. Now here we're looking at what the alternator is putting out. It's 66, let's say 66 volts or 66 amps. Now I'm going to check the amperage that's going to the inverter. And you can see it's 65 amps. Inverter is just about balanced, or put it this way, the alternator is just about balanced. It's not charging or discharging the battery, it's just operating on its own. So let's see what kind of load we come up with that this will actually work at. Okay, we're 5.5 on that. And the other load is 1.4. Now the voltage see there, the voltage is 120. It's actually, well, it varies between 119 and 120. Okay, so it's handling this kind of load. So I'm going to do some calculations and determine just what you can actually put on this thing with the machine, with the vehicle running at idle. How large a load can you put on it before it starts discharging the battery? So I'm going to do those calcs and I'll get back. Okay, I think I've got enough information now to give you an idea of how much load you can put on a system like this, where we have an inverter, we have a standard alternator on a car or truck, and it's running at idle. How much load you can put on this steady state load. Okay, according to what my numbers were, it's about 828 watts. That's steady state. Now what I mean by steady state is if you have something like a refrigerator and the compressor starts, when the compressor starts it draws a lot more power for a very short time. And this system would be fine with that. You could double that, the output, and it would be fine. In fact, it could go quite a ways above that. And the battery will add a little bit in when it's necessary. But for steady state, that 825 watts, really about 800 watts, is about all you can put on there. Now, what is that going to operate? Well, you can operate a gas furnace. Gas furnace, if it's very small, it could run 200 watts. Bigger ones are going to run 350, maybe 400. Very old furnaces would be much higher than that. Gas furnaces. Oil furnaces would be about the same. Yeah, pretty much the same. Of course, obviously, you're not going to operate a heat pump or electric furnace. It'd draw far too much power. You could also run maybe a refrigerator. Refrigerator steady state is going to be 2 to 400 watts, unless it goes into defrost. Defrost is going to add in a bit more. Maybe you'd be up to 600 watts. So if you figured those two, the furnace and a refrigerator, you're going to be somewhere around 500 watts right there. And you can put a few lights on it, no electric heaters, nothing like that. Maybe another refrigerator, you might be able to sneak one in, and that's about it. If you're using LED lights, that's going to make quite a bit of difference. So that's pretty much all you could expect for this to operate continuously. Now I'm going to, the rest of this video, I'm going to increase the speed of the vehicle engine so that we can see if there's any way we can pull more power out of this. So let's watch that and I'll discuss afterwards. Now we're set up with about 2,500 RPM on the motor, and we have a load on there, and let's kind of check out what's going on with this load. Okay, in DC amps coming from the alternator, it's like 100. DC amps going to the inverter and than the load is 100. Okay. We're at 13.9, 14. We're just barely there. It may be drawing the battery down just a little tiny bit. Let's look at what's going on with the load and see what we're getting out of it. Okay, our voltage, again, is about 120. Our amperage is almost 9. It's 8.9 to 9. So I'd say 9 and 120 is what we're getting out of it. Now this is just about balance. This is just about all this thing can do. I don't think I could get any more out of it. Let's see if the alternator is overheating. Yeah, we're getting a little bit warmer, not too much. Yeah, about 260. So I'm going to go ahead and do the numbers on this thing so you can understand whether it was worth it to increase the RPM of the motor to do more load. Okay, a few final numbers and conclusions. We were putting out 100 amps out of the alternator. That's probably pretty much its max. It's supposed to be 132 amps, but I'm surprised I got 100 out of it. That was actually more than I thought. And it kind of balanced out because I was using 100 amps going into the alternator also. And so we had a total of, I think, let's see, 1,400 watts going into the alternator. And we had 1,080 watts coming out of the inverter to the load. So I'll round that down to 1,000. That's 1 kilowatt. And that's about all you get. Now, when I was at idle, I got 825, say 800. So we got maybe 20% more going to 2,500 RPM. I'm not sure it was worth it. It might be if you have loads for it, but in order to get the vehicle, you have to buy a fast idle for it, and that's expensive and so on. So I'm not sure that's valuable. The temperature of the alternator wasn't too bad, 260. That's probably still pretty viable. Again, you know, this was a battery charging alternator. It's not made for continuous use, but it may hold up for quite a while. So what could you do with this thing? I'm gonna make a conclusion that your best use of this is just for operating at idle and have a little lower capacity. It probably is viable to go quite a while this way. There's some question about whether running a vehicle at idle is good for it. I don't know that it's bad for it anymore. These injection systems are very precise, and so it may be okay to run it that way. In any case, there will be some wear on the motor no matter what. Is this viable? Yeah, I think it's viable, and I'm going to go a little farther. I'm going to do a video on how I put this together, the materials I use, and what I think should have been used, and why. And I'll also, probably going to be in a later video, but I will put an outlet in the bed of the truck so you don't have to open up the hood to access the inverter and so on. I mean, the way it is now, you could plug it in and then close the hood again. It would be fine. But I'll be doing that video on how this was put together and everything I use here pretty soon in the future. And that's it on this one.